Welcome to Independent Aircraft Investigations. My name is Richard Godfrey. Today we're going to investigate MH370 and we're going to present a plausible hypothesis as to what happened. By plausible hypothesis, we mean a reconstruction that does not claim proof, but which satisfies known physical constraints, aligns with independent datasets, and survives attempts at falsification using available technical evidence, as opposed to narrative speculation. Competing terminal scenarios were evaluated against these constraints. We will present an integrated end-of-flight reconstruction drawing from multiple independent technical domains and consistent across independent datasets, including the Boeing uncontrolled end-of-flight simulations, the Blely-Marchand controlled ditching scenario, the DSTG Inmarsat burst frequency offset analysis, the Inmarsat satellite timing, the whisper propagation geometry, the fuel exhaustion constraints, floating debris damage assessments, hydroacoustic recordings from CTBTO and IMOS, as studied by Lannell and Curtin and Cardiff universities, Southern Indian Ocean meteorology, and human factors timing considerations. The objective is not to assert intent, but to identify a physically and temporally coherent terminal sequence consistent with all available technical evidence. Independent aircraft investigations brings you the established facts. We provide traceability of all evidence to a source authority. We make a clear distinction between factual data and analytical interpretation. We operationalize ICAO Annex 13 by embedding investigative discipline directly into the production of each episode. This ensures the separation of factual material, analytical work, and narrative outputs, and they all remain clearly distinguished, traceable, and compliant throughout the life cycle of an investigation. If you find this analysis useful and want to see future independent investigations, then please subscribe to the channel. That helps ensure this work continues. This episode does not prove intent, motive, or final causal conclusions. Where interpretation is presented, it is identified as analytical inference and remains subject to revision as new evidence emerges. Aviation news is covered on Daily Airline News with Jeffrey Thomas, as it happens. This channel is reserved exclusively for in-depth investigations. So, the initial conditions of the MH370 disappearance. The pilot in command, the PIC, signed in for duty at 14:50 UTC. That's 22:50 local time on the 7th of March, followed closely by the first officer who signed in 25 minutes later. The Malaysian Airlines System Operations Dispatch Center, the ODC, released the flight at around 15:15 UTC. The PIC, an authorized examiner for the Department of Civil Aviation in Malaysia, was conducting the last phase of line training for the FO, who was transitioning to the Boeing 777 aircraft type from the Airbus A330. As the FO was certified functional during his last line training flight, no additional pilot was required as a safety pilot on MH370. It has been established that the PIC had assigned the FO to be the pilot flying for this flight, and the PIC was then the pilot monitoring. The PIC ordered 49,100 kilograms of fuel for the flight that gave an endurance of 7 hours and 31 minutes, including reserves. The planned flight duration was 5 hours 34 minutes, and this is evidenced by the flight plan, the load sheet, and the fuel docket. In accordance with the standard operating procedures, the SOP of Malaysian Airlines, radio communication on the ground was the responsibility of the FO, and in the air, the role is reversed when the FO is assigned as the pilot flying. MH370 took off at 16:41:43 UTC and reached the initial cruising altitude of 35,000 feet at 17:01:06 UTC. This is evidenced by the ADS-B, ACARS, and secondary civil radar data. The takeoff report was sent by ACARS at 16:41:58 UTC at an altitude of just 344 feet and shows the autothrottle was engaged. The climb report was sent by ACARS at 16:52:21 UTC at an altitude of 22,278 feet and shows both the autopilot and autothrottle were engaged. At 17:01:17 UTC, the PIC reported Malaysian 370 maintaining level 350. And this was acknowledged 4 seconds later by ATC. At 17:07:56 UTC, the PIC again reported 7370 maintaining level 350, which again was acknowledged 6 seconds later by the ATC. The PIC this time started with a noticeable hesitation and then makes a mistake with the flight number and says 7370, not 370. The call was also unnecessary and not standard operating procedure. At 17:19:30 UTC, ATC transmitted Malaysian 370 contact Ho Chi Minh 120.9er, good night, which the PIC acknowledged 4 seconds later, good night Malaysian 370. The PIC did not repeat back the radio frequency 120.9er. It is standard operating procedure for both pilots to remain in the cockpit until the aircraft is established in the cruise. Professor Kunzel from Marburg University in Germany conducted a forensic speaker recognition analysis of the voices from the cockpit. He used two methods, an automatic forensic speaker analysis system and a trained listener. The automated system creates a 60-dimensional vector every 10 milliseconds of the voices, the so-called mel-frequency cepstral coefficients, the MFCCs. They are a compact set of numerical features widely used in speech and audio processing. They describe the shape of the short-term power spectrum of a sound in a way that roughly matches human hearing. Known recording of the PIC and the FO were used, and they were compared to ATC recordings not only from the MH370 flight, but from 82 other pilots. All ground transmissions were confirmed to be from the FO, and all airborne transmissions were confirmed to be from the PIC. There were no imposter voices detected. Let's listen carefully at 1707.56. The PIC again reported 7370, maintaining level 350, which was again acknowledged by the ATC.
370, maintaining level 350.
And here is the FO requesting flight 350 at 16:26:22 UTC.
350.
And here is the PIC maintaining flight level 350 at 16:50:11 UTC.
350.
And here is the PIC maintaining flight level 350 at 17:07:56 UTC.
350.
I can detect the difference between the PIC and the FO voices, but I cannot detect any difference between the PIC's earlier and later transmission. Let's listen again to the second message in full.
370, maintaining level 350.
The message falters, but you can hardly pick up the mistake 7370, and I do not sense any stress in the voice. The last transponder message was received at 17:20:34.55 UTC, and that's 64.55 seconds after the last ATC radio message. Radio contact with Ho Chi Minh was never established. The last ACARS message was sent via satellite link at 17:07:29 UTC. This message contained 6 position reports every 5 minutes, covering the first 30 minutes of flight. The next routine report was expected at around 17:37:29 UTC and was never received. This means that the ACARS system was switched off in the cockpit. When the satellite data unit was powered back up at 18:25:27 UTC, the ACARS system was not switched back on. The ACARS data is normally forwarded to the operator Malaysian Airlines, the aircraft manufacturer Boeing, and the engine manufacturer Rolls-Royce. No messages were received, therefore no messages were forwarded to any of the parties after 17:07:29 UTC. An unidentified and unresponsive aircraft was detected by WMKC Kota Bharu Airport, the terminal area radar, inbound at 17:30:33 UTC. No attempt at an emergency landing was made at Kota Bharu Airport, and the aircraft continued past and eventually left radar range at 17:44:24 UTC. The same unidentified and unresponsive aircraft was detected by WMKB Butterworth Air Force Base, terminal area radar inbound at 17:46:34 UTC. No attempt at an emergency landing was made at either Butterworth Air Force Base or Penang Airport or Langkawi Airport, and all have 3,000-meter runways. And the aircraft continued past and eventually left radar range at 18:00:51 UTC. The Malaysian official report confirms the civilian primary radar track and includes the military primary radar observations. But the military radar data has never been released, so it is not possible to confirm this military evidence. And the CETA Inmarsat raw data logs and the civilian radar raw data and the ADS-B raw data from Terengganu Airport are all available in the public domain. Now let's consider the flight path constraints. Fuel exhaustion constraints, Inmarsat satellite timing, the floating debris drift analysis, and the whisper propagation geometry. The Boeing fuel analysis was part of the Malaysian official report, and the area marked in red on the screenshot is the maximum fuel range of flight MH370. The flight had to end somewhere within this area. The Inmarsat data defines a number of arcs moving progressively further south. The aircraft had to end up somewhere around the seventh arc, as that was the point it ran out of fuel. This is confirmed by the Malaysian official report, the ATSB reports, and also confirmed in a paper presented by Inmarsat at the Royal Institute of Navigation. The first item of floating debris that was found and handed in to the authorities was a flaperon from the right wing, and that was found on Reunion Island. The item weighed 40 kilos and was 2.32 meters by 1.26 meters. That's 7.6 feet by 4.1 feet. The item was confirmed from unique identifiers to be from flight MH370 and the aircraft registration 9MMRO. And since then, 8 further items have been officially examined and determined to be almost certainly from MH370. In total, around 60 items have been found. And oceanographers from CICERO and UWA have defined MH370 search areas based on their drift analysis. In a case study published on the 31st of August 2023, together with my co-authors Professor Simon Maskell and Dr. Hannes Kurtzi, we examined the use of radio waves from the weak signal propagation reporter, WHISPER, and the historic database called WhisperNet. Signal level and signal frequency modulations can result when an aircraft flight path intersects with the propagation path of a WHISPER link. WHISPER tracking of aircraft is not yet a proven technology, but initial results align with the Boeing fuel range and Inmarsat satellite arcs. The estimated WHISPER-based MH370 crash location aligns with the UWA drift analysis, but not the CICERO drift analysis, nor the IG and Blely-Marchand flight paths. Now let's look at the flight path terminal constraints, the Boeing uncontrolled end-of-flight simulations, the Blely-Marchand controlled ditching scenario, the DSDG Inmarsat BFO analysis, the floating debris damage assessments, the hydroacoustic recordings, and the Southern Indian Ocean meteorology. The Boeing 777 aircraft can theoretically achieve an unpowered glide ratio of approximately 17:1. And that means for every 1,000 feet of altitude lost in an unpowered glide, The aircraft can travel a distance of approximately 2.8 nautical miles. If MH370 was at an altitude of 40,000 feet at the point of fuel exhaustion, the aircraft could glide more than 100 nautical miles with an average rate of descent between 2,500 and 3,000 feet per minute. In April 2016, the ATSB defined a range of additional scenarios for Boeing to simulate in their engineering simulator. Reasonable values were selected for the aircraft's speed, fuel, electrical configuration, and altitude, along with turbulence levels. 10 simulations were performed under the assumption that there were no pilot inputs following fuel exhaustion and that the autopilot disengaged either after the first engine flamed out, that was in 4 cases, or after the second engine flamed out in the remaining 6 cases. In all cases, the aircraft crashed within an area 44 nautical miles north to south and 39 nautical miles east to west. The possibility of a controlled ditching was carefully considered. Something occurred on board MH370 just before it reached the 7th arc, which interrupted the power supply to the satellite data unit, the SDU. It takes a minute for the SDU to reboot after a short interruption of power. Since early in the search, analysis of the aircraft's fuel consumption and endurance and the characteristics of the final series of SATCOM transmissions had yielded fuel exhaustion as the most likely explanation for the power interruption. However, it was considered that the SDU reboot could be explained in other ways if there was someone active in the cockpit and preparing the aircraft for a controlled ditching. If the aircraft was being actively controlled during the final segment of the flight south into the Indian Ocean, a series of step climbs, which must be initiated by someone in the cockpit, could have resulted in enough fuel at the end of flight to perform a controlled ditching under power rather than an unpowered glide. At the time the 7th arc was generated by the aircraft logging back on to the SATCOM system, the aircraft could have been descending in a normal landing configuration, including full instrumentation and full hydraulic power available for all flight control surfaces, including slats and flaps. At normal rates of descent, around 2,000 feet per minute, the aircraft could have flown approximately 120 nautical miles from the top of descent at an assumed altitude of approximately 40,000 feet down to sea level. If the Boeing ditching procedure were followed, then there would have been turns at lower altitude, firstly to the south or southwest into the prevailing wind, and finally a turn close to sea level to land the aircraft parallel to the prevailing seas. On 8th of March 2014, the sun was already 6 degrees above the horizon by 001930 UTC as the aircraft reached the 7th arc. Sunrise had been 24.5 minutes earlier at 23:55 UTC. The surface of the ocean would have been visible in order to judge the touchdown on the sea's surface. In addition, at that time, the aircraft was close to fuel exhaustion, and therefore the lightest state it could be. and therefore it was possible to make a controlled ditching with the lowest possible approach speed, with flaps extended in accordance with the Boeing ditching procedure. And Captain Patrick Blelly and Jean-Luc Marchand estimate in their ditching scenario a crash location between 45 nautical miles and 67 nautical miles after passing the seventh arc, and around 105 nautical miles to 127 nautical miles from the sixth arc. They estimate the altitude when crossing the seventh arc at 19,500 feet. On the 20th of June 2016, the inboard section of MH370's right outboard wing flap was found on Pemba Island, east of Tanzania. And this was an important development since evidence of flap extension at impact would indicate a controlled descent, and thus increase the search width required to the southeast of the seventh arc. And conversely, a retracted flap would indicate an uncontrolled end-of-flight scenario, much closer to the seventh arc. The ATSB stated in their conclusion, in their report dated the 2nd of November 2016, that the outboard flap failure analysis concluded that the right outboard flap was most likely in the retracted position at the time it separated from the wing, i.e., not in the extended position. And from June to July 2016, discussions within the ATSB regarding the end-of-flight controlled or uncontrolled descent scenarios continued, and the analysis using the Boeing end-of-flight simulation again considered the distance beyond the seventh arc that was now reasonable to presume regarding a possible uncontrolled descent. And further consideration of the seventh arc BFO values was underway by the DSTG, and it indicated rates of descent of the aircraft of the final arc could be ascertained. And Ian Holland from the DSTG in Australia concluded in his paper titled MH370 Burst Frequency Offset Analysis and Implications on the Descent Rate at the End of Flight, which is dated the 15th of January 2018, that the rate of descent of MH370, based on the Inmarsat satellite data, was between 13,800 feet per minute and 25,300 feet per minute. And the acceleration was around 0.68 g in the 8 seconds between the last two BFO data points. The range depends on the assumed ground speed and the track and the reason for the satellite data unit reboot. Henrik Rydberg of the Independent Group already published a descent rate of 15,000 feet per minute based on the final BFO data and assuming a speed of 500 knots and a southerly track on Duncan Steele's website in June 2014. Data from 11 different hydroacoustic stations has been investigated in the case of MH370. 3 separate teams have looked at the data. Teams from Curtin University, Cardiff University, and Los Alamos National Laboratory in the USA. They found no conclusive evidence of an underwater acoustic event or definitive impact signal attributable to MH370. This is consistent with a ditching attempt, whereas the Debris damage and the rate of descent and the flaps not being extended is consistent with a high energy impact. The whisper analysis shows multiple turns and two step climbs during the flight of MH370. The Boeing fuel range and endurance analysis implies step climbs to around 40,000 feet. And the absence of wreckage close to the seventh arc is consistent with two possible scenarios. Either that the wreckage has been missed in the underwater search, or that MH370 did in fact glide beyond the 30 nautical mile search width that was covered in the previously searched areas between 2014 and 2018. The weather in the southern Indian Ocean at cruising altitude was dominated by strong winds from the west at up to 70 knots or 81 miles per hour, with temperatures between minus 44 degrees Celsius, that's minus 47 degrees Fahrenheit, and minus 51 degrees Celsius, or minus 67 degrees Fahrenheit. And it was partly cloudy with some rainfall. On the surface, the winds were 18 knots, 21 miles per hour from the south, with temperatures between 17 degrees centigrade, 63 Fahrenheit, and 21 degrees centigrade, 70 Fahrenheit. The waves and swells were between 2.5 meters, that's 8.2 feet, and 4.6 meters, that's 15.1 feet. The first systematic doctrine-level use of aircraft as intentional murder-suicide weapons occurred on the 25th of October 1944, when kamikaze pilots of the Imperial Japanese Navy Air Service attacked US ships during the Battle of Leyte Gulf in the Philippines, including the sinking of the USS St. Lo. The first commercial airliner deliberately crashed by a member of its own flight crew was Japan Airlines Flight 350 on the 9th of February 1982. And since then, there have been 5 further confirmed cases of commercial aircraft intentional murder-suicide attacks perpetrated by flight crew members, plus one other jurisdictionally disputed case that was the case of Egypt Air 990. And 9/11 remains the only time commercial aircraft were hijacked by terrorists and used for intentional murder-suicide attacks. Most of these events involve substantial, sustained flight in cruise before the aircraft was used as a weapon. The average flight time in all these cases was 1 hour and 28 minutes, and several of these events involved extended periods of normal flight prior to impact, indicating sustained intent rather than purely impulsive action. German wings was even rehearsed the day before. Air Botswana Flight 3 involved 2 hours of negotiations between the pilot and the ground. And MH370 involved a home flight simulator session of 1 hour 12 minutes a month before the crash flight. Many analysts have taken the evidence of the home flight simulator not just as circumstantial evidence, but as a smoking gun. Many other analysts have pointed out, if you want to commit suicide, why wait 7 hours, 37 minutes until fuel exhaustion? The high descent rates of around 15,000 feet per minute, so per the DSTG analysis, and the flaps being retracted as per the ATSB analysis, align with a high energy impact scenario. The lack of acoustic signal detection from the impact and a possible attempted ditching align with a low energy impact scenario. Boeing showed that it's possible to recover from a 15,000 feet per minute dive, and conversely, it is possible to experience a catastrophic outcome of a ditching attempt in adverse weather conditions or sea state. There have been a total of 1,143 aerial hijackings since 1931. And this number of annual attempted hijackings peaked in 1969, and there were 86 attempted hijackings that year. And hijacking was then made illegal in nearly all countries, and metal detectors and baggage searches were brought in at all major airports from 1972 onwards. And hijackings occurred for many reasons: political, extortion, or forced transportation to a chosen destination. There was almost always a demand of some form. The only time no demand was made was 9/11, and a very small number of other cases which were put down to mental illness and psychoses. There have been no demands made in relation to MH370. It is theoretically possible there was again a hijacker suffering from a psychosis. If one of the pilots exited the cockpit after the cruise was established at 17:01:17 UTC and before the transponder was switched off at 17:20:34 UTC, it might have given opportunity for a hijacker to enter the cockpit in that 19-minute interval. This would require a rapid incapacitation of both pilots, a person with no coherent objective, and a subsequent automated or poorly managed flight. We know that the co-pilot's mobile phone was detected over Penang Island at 17:52:27 UTC. The subsequent flight was automated, but still included turns and step climbs, and possibly even an attempted ditching. MH370 shows that absence of demands does not exclude hijacking, but it does force the event into a very narrow class: a silent event, a non-negotiated event, and a destructive or internally driven event. And there is a cluster of cockpit-controlled no-demand loss events that some are disputed. The list is from Japan Airlines 350 in 1982, Royal Air Maroc 630 1994, Silk Air 185 in 1997, but that one's disputed. Egypt Air 990 in 1999, and that is also disputed. Then LAM Mozambique 470 in 2013, Malaysia Airlines Flight 370 in 2014, which is disputed. German Wings 9525 in 2015, and China Eastern 5735 in 2022, which is disputed. Malaysia Airlines standard operating procedure required flight crew to have personal phones powered off before engine start. From the Royal Malaysia Police phone records and prior behavior, the PIC did not reliably comply with this rule, whereas the FO generally did. And the FO's phone detection is consistent with viability at that time. The FO viability is, of course, inconsistent with a rapid dual incapacitation shortly after cruise. The data is more consistent with continued cockpit normality past the air turnback and the FO viability well into the Penang overflight. In summary, the FBI evidence from the home flight simulator is not conclusive of a premeditated act by the PIC. It is only circumstantial evidence. The hijacker scenario requires the near-instant neutralization of both pilots between 1701 and 1720 UTC, and it requires someone else managing the structured turns and altitude changes. The PIC showed a speech disfluency with a pronounced A. He made a mistake in the flight number 7370, not 370, and he makes a call that is unnecessary, a non-standard operating procedure. The PIC also fails to repeat the Ho Chi Minh radio frequency, which again is standard operating procedure. There is a lack of supporting evidence for the psychotic intruder scenario, and the FO is still viable based on phone detection whilst over Penang. And that fact pushes any hypothetical takeover to a later point in time. And that creates cascading problems for the psychotic intruder scenario. Why delay violence? How is the cockpit access maintained? Who is managing structured turns and altitude changes in the meantime? At that point, the model stops looking like external hijacking and starts looking like insider cockpit control. And given the standard operating procedure phone off and the FO phone detection over Penang and the asymmetric compliance between the captain and the FO of the standard operating procedure, the rapid dual incapacitation by an external actor hypothesis becomes internally inconsistent. MH370 therefore continues to sit much more naturally in the same behavioral class as other silent, non-negotiated, cockpit-controlled losses, regardless of motive. Not because hijacking is impossible, but because the timing no longer works. A flight for 7 hours 37 minutes to around the time of fuel exhaustion is consistent with an attempted ditching scenario. The damage to the recovered floating debris is consistent with a failed ditching attempt. So, in conclusion, we present a plausible hypothesis, by which we mean a reconstruction that does not claim proof, but which satisfies all the known physical constraints and aligns with the independent data sets, and survives attempts at falsification using available technical evidence. Analytical inference does not prove intent or motive or causal conclusions. Our reconstruction indicates sustained cockpit control consistent with the deliberate diversion of the aircraft from its filed flight plan. On balance of probabilities and based on the available technical evidence, the sequence of events aligns most closely with a captain-initiated control rather than external hijack or rapid dual incapacitation. This conclusion is derived from timing constraints, cockpit voice attribution prior to the diversion, operational behavior, and the elimination of alternative scenarios that remain inconsistent with the observed data. It does not constitute proof of intent or motive or legal culpability. The possible third-party intervention or alternative cockpit dynamics cannot be completely excluded on the basis of the currently available evidence. However, when tested against physical, temporal, and procedural constraints, those scenarios appear less consistent with the overall reconstruction. Any determination of responsibility would ultimately require recovery of the main wreckage, including the flight data recorder, the cockpit voice recorder, and forensic evidence from the cockpit area. Meanwhile, we have had around 1,000 comments and questions, and next Tuesday, the 24th of February, we will publish a question and answer session on the disappearance of Malaysian flight MH370. Next Friday, the 27th of February, we will take a look at the crash of Air India flight AI-171 soon after takeoff from Ahmedabad Airport. Please leave any comments or questions you may have. We will address the key points in the next episode and publish responses on YouTube and on our website, mh370search.com. Thank you very much for watching, and please subscribe for future investigations.